You say Dr. Eli. You call it whatever.
Well,
not whatever. Let's not go there. Let's not go there. All right, so if you take a look at this, see if you can think what you can come up with for the equation. Okay, what you can come up with for the equation. Or at least what parts. If you can't come up with the whole thing, maybe you can come up with pieces of it. All right, Mason, it's been a while. What you got for us?
Well, I know the denominator would be x plus 2.
All right, the denominator is determined by the vertical asymptote. Since it's a -2, the denominator is x plus 2. Yes. Yes, you got that part right. All right, what else can we get from here, Clev?
Can't you, since the horizontal asymptotes at 2, can't you put 2x on top on the numerator?
Okay. Yes, and a little bit more, because that does fit with what the horizontal asymptote is, but what, at this point, what doesn't it agree with? Does anybody know? The intercepts. Okay, so there does have to be, like you said, this satisfies our vertical asymptote, this satisfies our horizontal, but the x-intercept isn't satisfied. How does that come into play? Or where would that come into play at?
That'd be 2x minus 3 on top.
Close, depends on how you're writing it. So if you say this, you're on the, is that how you made it?
Minus 6.
Oh, you said -6. Okay, now we're good. Now we're good. Now here's what I would do, and this is absolutely fine, because you actually took it one step further. But since you got a vertical asymptote at -2, that's x plus 2. X-intercept of 3, that shows up in the numerator as an x minus 3. So that would be this quantity, x minus 3. Since the horizontal asymptote's at 2, you can just put a 2 out in front, and he distributed it. You can distribute it or leave it. It doesn't matter. Okay, but you have to have the x minus 3. The y-intercept really does not come into play, with the exception it's kind of like a checkpoint. So if you plug in 0 into that function, do you get back -3? Okay. And if you do, then you can be confident that it's right. But we satisfy all the cases. All right, if you did not do number 10, do number 10. Otherwise, kind of check through here on these answers, and I'm gonna come by and I didn't get a chance to do it on the computer. I'm just gonna come by and check off your homework now and see, let me know if you got any issues. Okay. Okay. Okay.
So we not doing that?
You get them all played.
This is the first thing I feel like show like what
Even though there's nothing to break down.
I don't know what I did there, because for x-intercept, you set x equals 0.
This is the thing.
For x-intercept, you set u equals 0.
Yeah, okay. And then you gotta have,
You gotta get 40.
you gotta have, you gotta have 2 pieces. like on each side. That should be a negative.
Wait, you got the horizontal axis of 44.
Did you check?
Yes.
All right.
I got
You're one, right? That means that makes it more complex. Make sure you understand that it goes along it.
I'm not holding out with my master for a while. Otherwise I'm gonna start crying.
Should go.
Oh, Vince. I'm not mentally.
You're gonna want.
Oh, I just got my nails done, I'm gonna chop my hair. I'm gonna be a new person.
All right.
The first thing you said was, what if I just throw
All right, you were absolutely.
like right now in the pull up?
Can I just put my mouse on?
On next year.
She said the same thing.
And you forgot the
Well,
video,
like
the one day I'm not.
that'll be your second, but
I
that'll
just put that down.
Yeah, but
Why
this
is it
wasn't on there, just the,
I'm thinking
this
about
year, this,
I like
the guy.
I would say I like my partner. That's being weird right now though. I think it's like interesting. I know they get
No, I guess not.
I like the look of them, but I like the
Yeah.
they get them started right before we- So, and my mom.
Alright, so six, make it one.
I just get a lot of big.
Picked up, we'll get there. All right, what do we got here?
Yeah.
Okay.
Hey, that's right.
Big one.
I don't know, like, my girl hair will make me say it.
Yeah, that's really big. I wanted to finish my conversation myself, if you call it, and then, my mom was like, absolutely not. Yeah. I did. Well, literally.
No, it wasn't. So I did.
Excellent, thank you.
I had two out there.
No, I have these little, I have mine brands, but then they're not hard to put in. Yeah. So like the soccer and stuff, I put them in and out all the time. So
I should buy butterflies.
it's so annoying. Like, you can do,
We're yellow.
or like they look like, I know, I have like three pairs of little tiny things. I just never wear them because I can't. Or if I do that, probably should be sure.
I could have all stuff in them.
So
using 3.5.
I think it was.
So you need like 15.
We also got, really, I always do that.
I know.
Like usually, okay, I got trouble this time, so it's been college, but it's like most of them. Yeah. I think that's like fine, but they have like a special one right now. That or weave is really like, yeah. It could be that, my prices are different every single time I go, even if I get the same thing. Yeah. But if I just get the regular polish for, wait, it's too weird. No, so definitely.
I know my friend.
Yeah, like if I found the pet food,
I know.
but if you get gelatin, I like if you get gelatin, it's like 50. But if you get just regular polish, it stays just as long, I think. Yeah, then it's not bad. And then to get just gel on like your actual nails is $25. Which is like not normal. Plus I love this one. She never charges me for extra stuff.
Hey, I'll get to number 10 here in a second. Let's kind of make sure you go through here. You did not need to list the oblique asymptote, though you just, if you could have. All right, for 5. Make sure you got x equals 4, x-intercept of 0, 0, y-intercept of 0, 0, and then your horizontal asymptote y equals 3. You gotta pick 1 point to the left of that 0, 0. I picked -4. I gotta pick 1 point in between 0 and 4. I picked 2. And then 1 point to the right. Now I just had 2 of them. You just needed to have 6 or 8. You can always do extra points, but that's what this graph would look like. Make sure that on your graph, when it goes to the left, if there's a horizontal asymptote, it must travel along that horizontal asymptote or oblique. And to the right, it must travel along that. Okay, that's key. So this could not like go up to infinity. It has to go along that asymptote. 6 was already up there, but just double check. If you, and the biggest things, like if you just make a careless mistake and you plot it in the wrong spot, like this is -3/2 and you accidentally put it at 3/2, and everything looks messed up. You might just go back to the beginning and then just replot things or recheck things. But vertical asymptotes are 2 and -4. Okay, here and here. Horizontal at 0 because the degree of the numerator is less than the degree of the denominator, so it has to go towards 0 to the left and to the right. I really only need 1 point past the asymptote, so you just tell it whether it's above the horizontal asymptote, which in this case is the x-axis, or below it. And then you got these key points here, 0, -3/8 is your y-intercept. And then I picked 1, -1. Okay, you need that one there. And then one in between -3/2 and -4. So I use -3 for those. And 7, factor when needed. Okay, factor when needed. So you get 3 and -3 as your vertical asymptotes. It does hit at 2 and -2, and it just barely goes over that x-axis, but it will at 4/9. And then it has to be going along the horizontal asymptote to the left and to the right. Okay. All right, any questions at this point? All right, 8, again, factor numerator, factor denominator. This was a difficult one because the picture is not quite what you're used to. It does go down below the x-axis and then comes back through our x-intercepts. 3, 0, and -1/2, 0. I hit pick -8 and then -4 just to make sure I had what was going on this left side. Because -4 is 12.25, a little bit above the graph, but it has to come down through there. And let's see. Oh yeah, and then it will just travel again along that horizontal asymptote. I got, what is that x-intercept? -1/2, so I picked -1 just to double check. Well, actually I needed to pick that one to make sure I know it's going up vertically on that, towards that asymptote. 10. All right, what'd you get for 10 as you take a look at that graph? Connor, did you get something?
I put 3x over x minus 1.
3x over x minus 1. X minus +1 gives me x minus 1. That hits at 0. Horizontal asymptote at 3. I agree. That's the same degree. Same degree on top and bottom. And then that bottom one, okay, 2x squared over x minus 2 times x plus 2. Okay, 2x squared. You got that 0. And the one thing is, this has to be x squared. If you just put, say, x, or even if you put 2x, what would that give you for a horizontal asymptote if it was just an x? Or just 2x? It would give you 0, okay, because the degrees would be different. So to make sure the degrees are the same, you just make it squared, okay, for that. All right, test, Tuesday, Wednesday. Okay, no calculator, not even the red calculator on Tuesday. Okay, there's not a ton of computation, but what there is, you need to be able to do on your own. All right, just a quick overview, just pay attention. We'll write down a few things here in a minute, but you won't I'm just listing everything. Complete the square, put a quadratic in standard form. Find the range of a quadratic function. That's all from 3-1. 3-2. What's the degree of the polynomial, the end behavior, zeros, and then sketch those graphs. Okay, so does it bounce? Does it bend? Does it go straight through? So what's the multiplicity of the roots? Dividing polynomials, synthetic division, which use that a lot for the zeros. Apply Descartes' rule of signs, rational root theorem, and then 3-5 and 3-6. Okay, 3-5 we got complex numbers, and then 3-6 that's all the graphing with the vertical and horizontal asymptotes. All right, here's what the no calculated part will look like. 60 points. Rewrite in that vertex form. We'll do one like that here in a second. Find domain and range. End behavior and degree. Find the roots of or zeros of polynomials, rational, irrational, and complex. Sketch them, just give me the shape. Descartes' rule of signs and graph rational functions. No oblique asymptotes. Okay, I won't have that on there. Calculator part. There'll be some true-false questions. Rational roots for an equation. You don't necessarily have to solve all of them, just have to list the roots. Word problems from the quiz. Make sure you have your quiz. And those of you who were quarantined, okay, you either have it on. I might still have the one if you turned it in, or make sure you still have your version. Name that graph, find the equation, write the function given the roots, and then find roots of polynomials, irrational, complex. All right, take a look at these two. What is the minimum number of times the 6-degree function can hit the axis? Maximum, sorry. And then what is the minimum number? All right, see what you come up with. Thomas, you gonna answer this? You just got your hand up.
All right, but
What's your question?
I have no quiz, but I don't know which ones they got wrong.
All right. Yeah, let me see here. You turned yours in on email, right?
Yeah, I turned them on. Yeah, I did.
All right. I think I might have printed it off for you, I guess.
I was on that, I'm going about 10 times.
Yeah.
Minimum is the also.
Reading, I said. Yeah.
I'm thinking guess 6.
It's 5%. It's not to be possible. It's gotta be 6.
I think it's 6.
N minus 1. What does that want to do? Fine.
I think it's 5.
Adam.
Oh, Lord. Oh, okay. You just give me. Thank you.
Okay,
Great, awesome.
Yeah, because you have one that has 2 different things. A 61 function is
That's your, check.
and positive, so it's
Wait,
like this.
Yeah.
And then
Go to where you put it in.
one.
So I think I wrote that
I don't.
I didn't expect my nails to be oily.
That's my stuff.
Wow, this is.
I thought it was more of a navy, but then I put it on it, it was more like a. Plus I was like, emailed it to them. I said that when I was telling you guys. And then he said it, like, look at that stuff to talk about, so I figured that's what he was doing. And then after he was like, on this thing, like, and then this thing, he said, like, trying to support it, right? I go, yeah, that's fine, like, well, it actually need to go to the he said that, I was just like, and I was like, please. And then he was like, oh, like, you need to tell me. I know, I was like, I like that, well, there's no right number.
Alright.
I guess there's some.
Right.
Yeah, that's just how it looks.
Alright, so I graded on there, I thought it supported it. Alright, what do you got there, for me? Audrey, how about the maximum number?
My guess is 5.
Your guess is 5? Oh,
Might be 6.
but now you're gonna say 6.
Ooh, I think it's.
I think it's 7.
6.
Oh.
6. Minimum number. Minimum number. Never mind.
I said 2.
You said 2. I'm gonna say lower.
Oh, 0. 0.
0.
Yeah. Yes, sir.
0. Okay. Alright, here's why. Listen up here. Think about a quadratic. You got f of x equals x squared plus 2. It's going to be moved up to, just make it x to the 6. So f of x equals x to the 6 plus 2. Then it's just, it'll look the same thing, it's just been moved up. Okay. So anytime you shift an even function, can be shifted up. Okay. For that. All right. Now create a 6-degree equation. You create it. That hits the x-axis exactly 2 times. Now I'll give you a little suggestion. Okay, keep it in its factored form. Like, don't try to do like 2x to the 6th plus 5x to the 5th, and then just think about it in its factored form. Okay, what would that look like? You know, this is like the no calculator part of the test too. You gotta have that understanding.
Got the low socks on today. What about that? What's that matter?
All right, so for this one here, anybody got? Ty, what do you got?
X plus 3 cubed and then x minus 4 cubed.
Okay, x plus 3 cubed, x minus 4 cubed. Yes, that'll work. That's all you need. Now, it's really anything here as long as they add up to 6. It could be a 2 and a 4. It could be a 1 and a 5. That doesn't matter. But it's going to hit 2 times.
Can't you just move it down, like x to the 6, like minus 4?
Okay, x to the 6 minus 4. Yes, that'll work too. This one, at least you can tell where they're at. But no, that's a good point. X to the 6 minus 4 would hit twice. Okay, as well. All right, rewrite the following. Let's take a look at some specific things from some specific sections. Rewrite the following: y equals a times x minus h squared plus k form. All right, I'll give you this form. You don't have to memorize the form. Okay. All right, for this, if you have a number in front of the x squared, this is where you want to factor that number out. So I'm going to make this into y equals 3 parentheses x squared minus 6x. Leave a spot there. Okay, leave a spot there. And that's where we're going to complete the square. So now I get y equals 3 x squared minus 6x plus, remember it's always a plus, minus 11, and then we got to figure out what we have to put in that last spot. All right, let's complete the square. Take half of negative 6, which is negative 3, and then square that. Okay, so the 9 goes here. What's going to go in that other spot? Negative 27. Because it's multiplying 3 times 9. We got to counter that. And so I get y equals 3 times the quantity x minus 3 squared minus 38. Okay, so that's in that quote vertex form. Now from here, identify the vertex and identify the range. All right, see what you come up with. Identify the vertex. Question, Dominic?
Why is the 27 negative right now?
Okay, we are on the same side of the equation. You have to treat this as 3 times positive 9, which is positive 27. So really, we changed that side of the equation by a positive 27. I got to counter it with a negative 27. Because so in the end, now I know when we did circles, if I added something at 9, I added a 9 on the other side. But since we're on the same side, I got to counter it with the opposite of it. Okay. All right, vertex, Tyson, what do you think?
I don't know.
Good thing we're reviewing. Okay. All right. Vertex is just what's in the parentheses, opposite of here, but same sign there. It's 3, negative 38. 3, negative 38. All right. Now you need that for the range as well. So from here, if that's our vertex, the original one had a positive x squared, so that means it opens up. And so the range is going to be negative 38 to infinity. Don't forget, this will come into play. The x equals negative b over 2a. Remember that's to find the x coordinate of the vertex, or actually I think we use h. They give you the x coordinate of the vertex for that. All right, so be able to convert that, write it in that vertex form, find range, find the vertex. Descartes' rule of signs. I just want to know the possible number of positive zeros, possible number of negative zeros. Okay, for that. All right, this is one of those things, like if you remember it, it's easy. If you don't remember it, it's impossible. Okay, so you can lose points, like if you kind of forget. All right, do you remember how to use Descartes' rule of signs? Okay, for this one. Okay?
Yeah.
Yes. All right, what am I doing? What's the only thing I need to do?
You look at where the negatives turn to positives, turn back to negatives.
Okay, how many do we got here? What do you think? 3, good. Negative goes to positive on that first one. That's 1. Positive stays positive, but then plus 7 goes to minus 8. Minus 8 goes to plus 20. Okay, so that means we have 3 or 1 positive zeros. 3 or 1 positive zeros. Now for The negative zeros, you plug in negative x and do the same thing. Now, when you plug in negative x, it only changes which terms, which powers. Only the odd powers. If you do that one step, fine. Or if you plug it in and then rewrite it. And so this will stay, negative 2x to the fourth will stay negative. 2x cubed will flip to negative 2x cubed. Positive 7x squared will remain the same. Minus 8 will flip to positive 8x, and then the plus 20 will not be affected. So now that is your new function that you want to look at. Now in this case, it only has one change of sign. So we get 1, 1, negative 0. Okay, for that.
Why is it 3 or 1?
You always, because complex roots come in pairs, if there would be complex roots, it's going to take 2 out at a time. So if it would be 4 changes of signs, you would have to say 4, 2, or 0. You always subtract 2.
Okay.
If it was 5 changes of signs, you'd say 5, 3, or 1. Okay, but since 1, when you just have 1, you subtract that, it gives you a negative. That doesn't work.
Okay.
Okay, so you got to say that.
Okay.
Okay, no calculator part again. Can you take this and do you know how to go through the whole problem to solve it? So we got x cubed plus x squared minus 8x minus 6. All right, so copy down and kind of think what the strategy is. And I was just asking for all the zeros. All right, this is where we do the rational root theorem. We do our A's and B's and figure out which ones we're going to test. There's no constant in front of there, which is nice, which makes A plus or minus 1. B are all the divisors of 6. 1 plus or minus 2, 3, and 6. And now our possible roots are B divided by A which is just the 1, 2, three, and 6. All right, you pick one, do synthetic division. Go ahead and just pick one. Hopefully somebody stumbles on a root. If you don't get the one in the first try, I mean, you can try a second one, but I wouldn't go too crazy. But all we need is to find one root. And if somebody finds, let me know what you got, Elizabeth. Negative 3 is a root. So plug in negative 3. And 1, 1, negative 8, negative 6. Okay, that gives me 1 times negative 3 is negative 3. Negative 2 times negative 3 is 6. Negative 2 times negative 3 is 6, and then 0. So f of x equals, since negative 3 is a root, x plus 3 is a factor, and you got x squared minus 2x minus 2. All right, you try to factor that last one. If it doesn't factor, what do we have to use? Quadratic formula. Okay, this one doesn't factor. And And so I need to use x equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, plug those in, simplify, see what we get. Opposite of negative 2 is 2. And I get 2 plus or minus square root of 12 over 2. Make sure you simplify square root of 12, which is 2 radical 3 over 2. And now in the end, what do we get? 1 plus or minus square root of 3. So I got x equals, or my zeros are negative 3, 1 plus or minus square root of 3. All right, how many times does it actually hit the x-axis? 3. It would only be once if those had i's. They had i's. Square roots, it's still a real number, it still hits it. All right, I do want you to do this assignment to kind of review a little bit. This is for the no calculator part. This is a homework assignment.
Yeah.